Okay, we started with the power rule. Do you want me to remind you of what that is? Or are you good?
I think we're good.
Well, of course you are. You worked with it all year last year. Anybody else?
Quick reminder.
Okay, so
X, n plus 1 over n plus
what's the derivative of x squared? 2x, okay. What is the integral of 2x?
x. I get a third over 3. Oh, 2x. Sorry, I was doing it.
2x
squared over 2. Yeah.
And then the 2 plus 1 x squared.
Plus c.
Okay, so you add 1 to the exponent and divide by that exponent, right? So, and these, you should see the relationship between derivative and integral. Does that ring a bell? Okay, so what if I have, what's the derivative of the natural log of x? Okay, so if I do the integral of 1 over x, what do you think? No, no squared, just absolute value. Okay, you have to put the absolute value there because it's not, log is not defined in negatives. Okay, so we need to have that there just in case our limits are negatives. Okay. Yeah.
What if it's more complicated than just 1 over x?
Like 2 over x?
Or like,
We'll get there, Ben. Slow down a little bit. Thank you. So let's, let's look at that one. This is an example. Okay, so that is 5 ln x, right? The integral of that's 5 natural log absolute value x minus, what's the integral of that? All over -9. And, thank you. So you can simplify it for multiple choice purposes. This is -1/3, so I mean, there are lots of ways to simplify it. That's one. Did you say that's unhealthy?
no.
Any questions? It's 3 over 9 is 1/3. And then it's negative, so positive. Okay. All right. Open your books to 278. I want to just show you this instead of writing everything down.
Oh, basic trigonometric integrals.
Okay, pay attention to this.
Do we we get a
So-
sheet into the?
No, nothing. Sorry. Okay, so look at those basic trig integrals. So remember, what's the derivative of sine? Cosine. So the integral of cosine, okay, those same relationships apply. The integral of sine is negative cosine because the derivative of cosine is negative sine. And you can go through, and they all relate very directly to the derivatives that we learned. Okay? You're just going to have to memorize them. It's just plain and simple. Lots of stuff starting to pile up, so hopefully you've been starting on that.
You get no cheat sheet then. It's a valid question.
The ones I want to point out to you are something similar to what you might call the chain rule.
Should we write all those down?
No, you don't have to. I just want to point out the more complicated ones to you. So it's if you have something in here for derivatives that would kick the chain rule in, right? Because K and B would be numbers. For integrals, we don't really have a chain rule. You kind of have to think backwards. So the answer to this integral is sine.
Is that in the really yellow box?
7 or 7?
The difference here is that right there. Yeah, it's the yellow box on 278. So think derivatives. What's the derivative of sine? Kx plus b.
Negative cosine, or just cosine?
It's cosine. Yeah, kx plus b. I'm hearing that right. What's the derivative of the inside? Right, see that k? It doesn't occur here, right? When we take the derivative to go backwards, so we have to insert this 1 over k to eliminate that to get back to the integral.
Oh, that makes sense.
I'm just showing you why that 1 over k is there. So derivative chain rule, what we've been saying is the derivative and the antiderivative or the integral are basically opposites, right? But if you have something inside here, it messes with it a little bit because the derivative throws out a chain rule. And I have to have something to counteract that as 1 so I can get back to the original integral. Okay. I see a couple of head nods. You can come up with it on your own, but it's just, we're just starting integrals. We don't want to throw that at you. There's also one for sine. It's similarly formatted. Negative 1 over k cosine. Okay. Right, exactly. Okay. So be careful on those. And let's do an example with that present.
Negative 28
Oh,
Yeah, go ahead and give it a shot if you want.
negative 1/8.
So the integral of sine is negative cosine. And you have the 1 over k. K is 8. And then what about this one?
Oh, geez. Plus
1/9 sine 9t. No. Derivative of cosine, or the integral of cosine is positive sine. Okay.
Oh, I was thinking the derivative.
Old habits die hard, huh? Yeah. Okay. Are you okay with those?
Yeah. Like, what are we learning tomorrow? This is in 3 days. We've already done.
Initial conditions. Getting rid of the constant, C.
Oh, duh. And then, okay, so after our quiz on Thursday, then we go into actual integrals.
Yeah.
Yeah.
Der-
I love the first one.
definite integrals.
Does anyone else notice that there's a one fraction in the status?
Oh, yeah.
No, it's so good though. I know that. I heard that.
I'd rather do calculus. So that's what we're gonna do. Any guesses? Yeah. Well, that was complicated, right? We can also have that. Yep, you got it.
Hey, I have like serious questions.
Okay, serious.
Some huge scientists, where would I use this? If you're finding out like the rate of like diseases that are traveling and stuff like that, you can like plug as like an equation you can do with like calculus equation times derivative and stuff.
So population growth is exponential,
So this is
right? If you take the integral of the function showing that population growth, you get total number of people infected with Ebola.
Oh,
Done. You don't have to count.
yeah.
You just take the integral of the function that models it, and you're done.
That's awesome.
We'll get to that. That we will actually do. Okay, so good question. So if you're a biologist or maybe you're a doctor, or I mean, there are lots of people that can use this stuff. So
It's like if I know how to know where the advice to, then I understand like the concept.
okay, last one. What's the integral of 3e to the x minus 4?
3ax minus 4x
Okay, that integral is the same.
plus c.
There you go.
Ching, 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 ching.
Any questions? Okay. Do you shh. Not done yet. Do you want me to write the homework down again?
No, I have it.
No, yes. Which one?
Yes, please.
How about you try to like make an equation out of the homework so we do an equation to figure out what problem is due?
No.
I'm not that ambitious.
I just wouldn't do it because I couldn't solve it. I couldn't
Yeah, that's my scripture. That's my scapegoat for being my Didn't do it because I didn't know it was Yeah, number 3 was not there, wasn't it? The 3 through 9, I have 5, 7, and 9.
Remember number 5 was here?
Number 3 for class.
Number 5 was in the part A stuff, but has a log in it.
Oh, number 3 was.
Oh, it's number 3 then. Okay, so I moved it down here. So it's 3 through 9 odd instead of 5, 7, 9. Okay. It's the same homework, I'm just writing it different.
Okay.
Okay, there you go. You have about a half an hour or so.